we want to calculate the exact bounded area between the curves given by f of x equals x cubed and g of x equals 3x. To determine the area bounded by two functions, we use the formula shown below, where the bounded area is equal to the integral from a to b of f of x minus g of x integrated with respect to x, where f of x is the top function and g of x is the bottom function. So to determine the bounded area between two functions, it's important to always graph the functions so you can determine which function is on top and which function is on the bottom over the interval of the bounded region. Looking at the graph of the given two functions, notice for the bounded area on the left, the cubic function is on the top, the linear function is on the bottom, but for the bounded area on the right, the linear function is on the top and the cubic function is on the bottom. This indicates we'll have to set up and evaluate two definite integrals to determine the total bounded area. We also need to determine the x-coordinates of the points of intersection to determine the limits of integration. We could try to use the graphing calculator to do this, but we will only get decimal approximations for the intersection points on the left and right. So we'll go ahead and find them algebraically by setting the two functions equal to each other and solving for x, which gives us the equation x cubed equals 3x. Let's go ahead and try to solve by factoring. Let's subtract 3x on both sides, which gives us x cubed minus 3x equals 0. Next we'll factor out x, giving us x times the quantity x squared minus 3. The product on the left is equal to 0 when x equals 0, or when x squared minus 3 equals 0. To solve x squared minus 3 equals 0, let's add 3 to both sides and then take the square root of both sides of the equation. We are going to have a positive and negative solution. To get both solutions, we need to include a plus or minus on the right, and we have x equals plus or minus square root 3. Notice we have 3 points of intersection, 1, 2, and 3. On the left, the x-coordinate is negative square root 3. In the middle, we have x equals 0. On the right, we have square root 3. And now we have all the information we need to find the total bounded area. The bounded area A equals the integral first from negative square root 3 to 0, where again we have the top function minus the bottom function as the integrand function, which is, in this case, x cubed minus 3x. And then for the bounded area on the right, we have plus the integral from 0 to square root 3 of the linear function minus the cubic function. The integrand function is now 3x minus x cubed. And now we need to evaluate both definite integrals. Let's determine the antiderivatives. Integrating x cubed minus 3x, we have x to the fourth divided by 4, or 1/4 x to the fourth minus 3 times x squared divided by 2, or minus 3/2 x squared. And then for the second integral, the antiderivative is 3/2 x squared minus 1/4 x to the fourth. Now we determine big F of 0 minus big F of negative square root 3, and then we add that to big F of square root 3 minus big F of 0. So big F of 0 is going to be 0 minus big F of negative square root 3 is 1/4 times the fourth power of negative square root 3 minus 3/2 times square of negative square root 3. And we have plus big F of square root 3 is 3/2 times the square of square root 3 minus 1/4 times the fourth power of square root 3. And then big F of 0 again is 0. And now we simplify. We have the opposite of the fourth power of negative square root 3 is equal to 9, giving us 1/4 times 9, or 9/4. And then minus the square of negative square root 3 is 3. And 3/2 times 3 is 9/2, giving us minus 9/2. Now we have plus the square of square root 3 is 3. 3 halves times 3 is 9 halves. And then minus the fourth power of square root 3 is equal to 9. 1/4 times 9 is 9/4, giving us minus 9/4. And we can leave off the minus 0. We now need to simplify. Let's first obtain a common denominator by multiplying 9 halves by 2 over 2 here, as well as here. Simplifying inside the parentheses, we have 9/4 minus 18/4, which is negative 9/4. But then we have the opposite of negative 9/4, which is positive 9/4. And then we have plus 18/4 minus 9/4 is 9/4. And 9/4 plus 9/4 is 18/4, which simplifies to 9 halves. This indicates the total bounded area is equal to 9 halves square units. I hope you found this helpful.